In our last session, we discussed some basics of software engineering, and also we learned about what are the essential attributes of a good software. Today, we shall discuss about professional ethics of software engineering. Mainly, there are four professional ethics. They are confidentiality, competence, intellectual property rights of employers and clients is protected, and fourth one is computer misuse. Now, let us discuss it one by one. Confidentiality. This describes that you should normally respect the confidentiality of your employer or the clients, irrespective of whether a confidentiality agreement has been signed or not. The next one is competence. You should not misrepresent your level of competence. And third one is the intellectual property rights of employers and clients is protected. It means that you should be very careful to ensure that the intellectual property of employer and clients is protected. And next thing is computer misuse. It describes that you should not use your technical skills to misuse other people's computer. So these are the four professional ethics a software engineer should have. Next, we shall move on to case studies. Now we will be discussing few of the case studies. Among them, first one is insulin pump control system. What is insulin pump control system? An insulin pump is a medical system that simulates the operation of the pancreas, which is an internal organ of the human body. The software controlling this kind of medical system is an embedded system. So people, those who are suffering from diabetes, will use this system. As you all know that diabetes is a common condition where the human pancreas is unable to produce the sufficient quantity of the hormone, that is we call it as the insulin. Insulin is a hormone that is produced by the pancreas. So if it is not produced in the sufficient quantity, that condition we call it as the diabetes. Insulin metabolizes the glucose, that is a sugar level in the body, in the blood. The treatment for diabetes involves a regular injection of genetically engineered insulin. Blood sugar levels will be measured through an external meter, and they calculate the required dose of insulin, that is what the amount of the insulin that is required for a patient, that will be calculated, and they that need to be injected to the human body. But the problem with this kind of treatment is that the level of insulin required does not just depend on the blood glucose level or blood sugar level, but also it depends on the time of the last insulin injected. When the last insulin has been injected, that also matters in this kind of treatment. So this can lead to very low level of blood glucose or very high glucose level. So, if we do not calculate the exact time when it was the last insulin has been injected, so it may give rise to a new problem, that is a blood glucose level may increase, or we can or they can have a very high glucose level, or sometimes it can lead to very low levels of blood glucose. So what happens when this high level of blood glucose level will be there, or very low level of blood glucose will be there means, so it will give rise to a new problem, that is low glucose level is a serious condition where it can lead to temporary brain malfunctioning, and ultimately it can lead to unconsciousness and death. Whereas high levels of blood glucose level can lead to eye damage, kidney damage, and heart problems. So these conditions will lead to such kind of problems, such kind of severities. So to overcome these situations, automated insulin delivery systems are developed. These systems, what do? They monitor blood sugar levels and deliver an appropriate dose of insulin when it is required by a human body. So a software controlled insulin delivery system might work by using a microsensor which is embedded in the patient, which is used to measure some blood parameters. So, to measure the blood parameters, microsensor will be embedded in the human body, that is embedded in the patient, that is proportional to the sugar level, that is a blood parameter level which is proportional to the sugar level, that will be calculated, that will be measured. Then this is sent to the pump controller which computes the blood sugar level and the required amount of the insulin that is needed. It will then send the signal to a miniaturized pump to deliver the insulin through a permanently attached needle. So this working of a software controlled insulin delivery system you can observe in this diagram. So it consists of a needle assembly, a pump, a clock, and then alarm is there. So a sensor is there to measure the blood sugar level, and there is an insulin reservoir. Next, this figure shows you the activity model of the personal insulin pump. So here you can observe two circles. So this fillet circle, it shows the start of the activity, and a fillet circle within a circle shows the end of the activity. And this activity you can observe in the data flow model of the insulin pump, insulin delivery system will actually works. So firstly, a blood will be taken and it will be given to the blood sugar sensor. There you measure the blood parameters and that will be sent to the blood sugar analysis. That is, the blood sugar will be analyzed over there, and you will come to know what is the level of the what is the sugar level in the blood, and then it will be sent to the insulin requirement computation. Here in this it will actually compute the exact amount of insulin that is required, what amount of insulin is needed by the patient, and then insulin requirement will be given to the, that is what amount of insulin is needed, this detail will be sent to the insulin delivery controller. Here through the pump control commands, the insulin pump will be controlled, and what exact amount of insulin is needed, that will be delivered to the patient. So this is how our insulin delivery system will actually works. In next class, we shall discuss about a patient information system for the mental health care. So it is a second case study what you are having. We shall discuss it in the later classes. So far we have discussed what are the professional ethics of the software engineering, that is a confidentiality, competence, intellectual property rights of employers and clients is protected, and next computer misuse. Later we discussed case studies. In today's session we discussed an insulin pump control system. So how it works, what is insulin pump control system, and how it works, in which cases we make use of the insulin pump control system, that we have studied now. This shows the activity model of the insulin pump, and this is how the data, that is how the insulin delivery system will work. So it is has been depicted by using data flow model of a software controlled insulin pump. Thank you.